This tutorial will review the turning drilling process on a Mazak lathe. I'll start with a program open to editing and a part already faced to Z0 in a previous operation. Looking at a drawing for the part, we can see there is a 1.5-inch diameter hole through the entire part, with one end bored a bit larger. I will process the part by drilling all the way through, then later expand the bore in head 1 of our machine. I can drill a part in 2 different ways. Under point machining, I could choose drilling to use a live milling unit mounted on the turret, or I can choose turning and drill with a T-drill process using the main spindle with a rigidly mounted drill in the turret. Since it's a large drill and on center, I'll use T-drill. I'll drill on the face of the part in the left-hand spindle, and enter 1.5 inches for the drill size. Since there is already a drill mounted in the turret, it is automatically selected. Note, on some machines there is a simultaneous drill rotation option. This is for drilling a hole on center by simultaneously using a live milling drill and the turning spindle for increased productivity. In this case, I'll use the rigid mounted drill automatically selected, and move on. I'll skip priorities for now. For the drilling cycle, there are 10 choices. The first 5 are various types of bottoming holes. The second 5 are various types of through holes. The main difference between the 2 groups is the through holes add an extension to the program depth equal to about 10% of the diameter of the drill, adjustable by parameter settings. Detailed descriptions for each type of hole processing are shown in the Mazak programming manual included with your machine, including drawings like the one shown here, with detailed notes. For this tutorial, I will choose the highlighted number 0, drilling through type. Using AutoSet gives a starting peck depth of 1.5 inches, decreasing the depth of each peck by the depth 2 setting, until it gets to the minimum peck depth set in the depth 3 setting. I'll set the depth 1 setting to any number greater than the overall depth of my hole. A setting of 7.0 will ensure a constant single plunge into the hole. Note, the drill will not go this deep, it simply means it can, if needed. As long as my depth 1 is greater than the depth of the hole, depth 2 and 3 are ignored. AutoSet gives me an acceptable surface speed, but I'll increase the feed to 10 thousandths per revolution. In the first M code field, I'll choose M8 since coolant is plumbed directly into the drill at the turret face, giving me through tool coolant. Leaving the other M code fields blank, all that's left is to describe the hole. Start point Z is the front of the part, given as 0, and I'll set final point Z just a little through the part, at 6.2 inches. When choosing the final point Z, remember, since I'm using process number 0, drill through cycle, the drill will go a bit deeper than the programmed point. In this case, about 0.15 inches. Examining the automatically generated model, you can see my programmed hole has been added. It shows the hole 1.5 inches in diameter, starting at the face and going a bit through the part at the end. Looking at the TPC settings for this process, I'd like to point out a few settings. TC39 shows clearance at the face of the part of about 2 mm. This means the drill will start to feed in, about 2 mm in front of the part. TC11 and TC12 show the deceleration ratio of the drill, at the start of the hole, and at the end of the hole. This is given as a percentage of the programmed drilling feed rate, showing the drill will enter at half the programmed feed rate, and finish the hole at 70% of the programmed feed rate. You can edit these as desired, but I'll accept the defaults. With the hole drilled, we're ready to bore the part to size.